Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, I'm going to teach you about relations, mappings, and functions. We are also going to see different types of relations and which of these relations are functions. And we are also going to see how to find domain and range of all these relations. And I'll give you a lot of examples to find the domain and ranges of different relations. So let's proceed.
Let's talk about maps and relations. Relations in normal term means connecting two objects. Say, for example, X is a brother of Y. So, is a brother of is the relation, right? And this relation connects X and Y. So, X is related to Y if X and Y are connected with some condition. In mathematics, it could be an example could be X is related to Y if y is equal to say x plus 2, and this is a relation because x is related to y in a sense that you add 2 to x you get y. So this is how x is related to y in this case. So relations are always a condition that connects two objects. So we always write relations in terms of coordinates like this in ordered pairs x comma y. So x is the independent variable and y is the dependent variable which depends on the relation, and it also depends on what x is. So for example, y equal to x plus 2, and as you input the values for x you add 2 to this and then you get the value of y. So it depends on what you are doing to x and what the value of x is. So every ordered pair x comma y gives you the relation that x is related to y. So a relation R can be written as a set of all ordered pairs x comma y where x and y are real numbers. Okay, and you can write how x is related to y, for example, in such a way. This is in such a way that y is equal to say 2x plus 3 or whatever you want. Okay, so this is a typical notation that a relation is being written. So x is set of all x relation is set of all xy where y is related to x in some way or the other. And what is map? Mapping is the same as relations. It's the same thing, but when you say mapping, you get a set of values of x that are mapped to y with the relation that we have defined. So if I have x comma y in such a way that y is equal to x square, okay, then I'm mapping each value of x, say for example 1, 2, 3, 4. Each one of them is being mapped to another number in this set with this relation. So 1 would be mapped to 1 square, which is 1, 2 would be mapped to 4, and 3 would be mapped to 9, and 4 would be mapped to 16, and so on. So using the relation you map one element to the other. So that's called mapping, and this diagram is called map diagram. So you can have one set of x values mapped to another set of y values with the relation that's defined. So all these x value, the set of x values is called domain, and the set of y values is called the range of the relation. Okay, so if I have y is equal to say square root of x, that's the relation between x and y. So what is the domain of this? The domain of this is the value of the values that x can take. Definitely x cannot be negative, right? X cannot be negative. So x can take only values greater than or equal to 0. I can substitute 0 there. I can substitute any positive value in this place. So x greater than 0 will be the domain for this relation. Okay, what would be the range? What type of values you will get when you substitute different values of x in this? So when I start substituting different values of x into this, then I can either get, for example, let's say 4, x is equal to 4, square root of 4. Then y should be plus 2 or minus 2. So I can get both negative and positive integers or even real numbers. So if it was square root of 5, then I'll get plus or minus square root of 5 as my y value. So the range can be both negative or positive real numbers. So it is all set of all real numbers. So set of all real numbers is usually written as with two lines for R like this. So all real numbers is the range for this relation, and all positive real numbers is the domain for this relation. So this is what is called domain and range, which you will be doing in detail very soon. So, for example, if you have a relation like this, I told you relation is always written as ordered pairs, which means the first number comes from the domain and the second number comes from the range, which means 1 is related to 2, 2 is related to 4, 3 is related to 2, 1 is related to 5, and 2 to 8, which means that if you make two sets, 1 is related to 2 from the first pair, 2 is related to 4 from the second pair, 3 goes to 2, 1 goes to 5, and again 2 goes to 8. Fine. So this is domain and this is range. So if you are asked to find the domain and range of this, you just pick up the numbers from the ordered pair, the first numbers from the ordered pair, which means 1, 2, 3, and it's again 1 and 2, so you don't write them again in a set. So it's 1 and 2 and 3. Range is 2, the second numbers, 2, 4, you don't repeat 2, 5, and 8. So 2, 4, 5, and 8 is the set of range for this particular relation given. Okay, so this is range, and don't confuse with all the R's we are having here. Domain, range, and this is relation. So instead of writing this domain into, writing the same numbers repeatedly, we can just write 1, 2, 3, and we can see how it is related. 1 is related to 2, and 1 is also related to 5. So this has 2, 4, 5, and 8. 1 is also related to 5. So you can draw like this. 2 is related to 4, um, and 2 is also related to 8, right? 3 is related to 2. So this is what the relation, this relation can be written as, can be represented on a map diagram, okay, with lines going on from domain to range. So relation can also be written as like this, a relation such that x is related to y, where y is equal to say x plus 2. So this is another relation in terms of equations, right? So in this case, you know how to find the domain and range. So domain here is the values that x can take. So you can see that I can input any values of x here, which means I can input all real numbers. So x can take all real numbers. I can say -1, -1.5, -1000, or even plus 10,000, anything, or 0. So any number could be used for x, so that I can just have to add 2 to it and I'll get the y values, correct? So when I add to the 2 to the real number set, what is the set I'm getting here? This set would be another set of real numbers, right? So when I add 2 to any real number, we get a real number. Therefore, range is also set of real numbers. So this is another way of representing the relation and finding domain and range using the equation given. So we have already done what would be the domain and range of square root of x. So we just did this a few minutes before. We can also find what is the range and domain of x square. In this case, x is being squared. The number x is being squared. So I can input positive or negative numbers into this, right? Which means I can input any real number, which means the domain is any real number for this for this relation. What about the range? What about the values that y gets here? You are squaring a number, which means this is always positive. Therefore, the range is always a positive set of real numbers, which we write like this: positive real numbers. You input any x values here, square the real number, you get another real number, but it's going to be positive. So this is another way of finding domain and range. Next comes the types of relations. There are four types of relations. First example would be, let's say, a relation which says y is equal to, will have some other function, 2x plus 1 maybe. This is a linear function. If you know how to draw this, it will be a linear function going like this, right? This is y equal to 2x plus 1. So if I have a linear function like this, We know that the domain of this is going to be all set of all real numbers, and of course range is also going to be set of all real numbers. As you substitute real number, multiply by 2 and add 1 to that, then you are going to get another set of real numbers, right? So domain and range are both are set of real numbers in this case. What happens if I consider one x value here? Then I get exactly one y value. So I take any x value, I get exactly one y value. So one x value, I get one y value, right? So this type of relation is called one-to-one relations. One x value going to one y value is called a one-to-one relation, and usually this is a linear relation. It's easier to understand this from a linear relation. There are also other relations, like say for this exponential, and this is also, if you could notice, it's also one to one. So if for every x value you have exactly one y value. So these are all examples of one to one relations. Okay. So the second one would be, let's take y is equal to x square. Okay. If I consider this, the graph of this, then the graph looks like this. And if I go for a particular y value, say 4, right? If I take this y value, then you can see that minus 2 for x and plus 2 for x both are mapped to the same value for y, right? So plus 2 and minus 2 both are mapped to 4. Also, plus 3 and minus 3 would be mapped to 9, because that's the relation square of x. So which means you have two values of x giving one value of y. So two x's giving one y, right? It could be many x's giving one y. For example, if you take the sine curve, right, or even the cos curve, any periodic curve, you can see that if you say this is 0.8, and if you draw a line across, you can notice that there are so many x values that give the same y value, right? So which means many x value giving one y value. So this is called a many to one relation, where many x values give one y value. Okay, so the third type of relationship is something like this: y is equal to square root of x. So if I have x as say 4, then I can get the answer for y as plus 2 or minus 2. If my x value is say for example 16, then my y value would be plus 4 or minus 4. So which means I have one x value going to two different y values, right? So one x value going to many y values. So this is one to many relation. And the fourth relation is x square, example, y square is equal to say for example 9. So this is an equation of a circle. Okay, circle of radius plus radius 3. So this is 0, this will be 3, this would be minus 3. So in this case, if you can notice, say if I am taking a 2 here, okay, if you substitute 2 for x, so I'll get 4 plus y square is equal to 9. Therefore y is equal to plus or minus square root of 5, right? Which means I'll get plus square root of 5. So if I go across this, and minus square root of 5, right? And for plus square root of 5, I can also use, so in the place of 2, I can also use minus 2, and I'll get the same values, right? So for minus 2, I'll have the same plus root 5 and minus root 5. So two x values giving the same two y values, which means two x values giving two different y values. So which is minus 2 plus 2, giving me plus root 5 and minus root 5 both. So this is called, you should have guessed, many x values going to many y values. In this case it is 2 to 2, but in general the relation is called many to many relations. Okay, of these four relations, that is one to one, one to many, many to one, and many to many. Of these four relations, these two relations are very important. These two relations, if you have noticed, they give you one y value, whatever the x value is. So the value for y is exactly 1. So if you think about the functions, the function should is a machine, right? It's a machine where you input some x value and your output should be exactly one value. You cannot have two or three different outputs from a machine. So you need to have only one output, right? Therefore, for whatever x values you are giving in, the output should be only one y value. Therefore, these two relations are called functions. Okay, and these two are just relations, they are not called functions. So if you are talking about functions, then we are talking about relations which are 1 1 or many to one. Hope that's clear there. So one to one function, we had an example like this. Many to one function, we had an example like this, right? And when I was showing you how x values give you exactly one y value, here two x values giving exactly one y value, right? So if you draw any vertical line across the function, then those vertical lines should meet the curve exactly at one point, not more than that. In this case, we say that it's a function. So for any function, the testing is, say, if you have some function like this, and the testing is if you could draw lines, vertical lines on the curve, the vertical lines should meet the curve at exactly one point. If it doesn't, then it's not a function. So I can give you an example of the curve where it doesn't. So for this case, if you draw a vertical line here, it crosses the curve at three different points. Therefore, this is not a function.
Thanks for watching. If you like my videos, please subscribe to my YouTube channel, like and share all my videos with your friends and relatives. Thank you.